Hello, everyone. Today we're going to be talking about angle measurements, but we're not going to be working in degrees. We are going to be working in radians. So, up at the top, this is going to actually be pretty helpful for today because radians use a little bit, they're actually easier to work with when you use them in terms of fractions. And you'll see where this is going to come into a play in a second. But for example, if I'm going to take 1 minus 2/3, whenever we add and subtract fractions, we have to make sure we have common denominators. Common denominators. And that just means we want to get my two fractions to, again, have the same denominator. So if I have a denominator of thirds on this one, that tells you what to multiply by. And if you have 2/3, that means one whole one would be 3/3. And subtracting them becomes super easy. If I take 3/3 minus 2/3, remember the denominator is going to stay. And all we have to do is 3 minus 2, which is 1. So 1 minus 2/3 would end up being 1/3. If I did 1 plus 1/6, if I have denominators of 6, that would mean this would be 6/6. And again, denominator would stay the same, and we would add the numerators on top. 6 plus 1 would end up being 7. So final answer would be 7/6. So even if you work with some larger ones, if I have 2, that just means I have 2 groups of however many there are on the bottom. So 1 would be 7/7, 2 would be 14/7. And I can even do it, like I said, like here with larger numbers. 14 minus 2 is going to end up being 12, and my denominator is going to stay the same. So that would be, wow, my final answer. And the reason we're starting off with some fraction practice is because of what we're about to do. And we're going to be working with angle placements, but we're going to be working in something called radians, and we're not working in degrees anymore. So you're not going to see a degree measure. Most noticeably, you're going to notice that typically with radians, you're going to see there's no degree sign, and usually pi is almost always involved. Because how you work your way around the unit circle, if this was in degrees, we would be 0 degrees, or if you worked your way around completely, it would be 360. Up here, it would be 90 degrees. Obviously over here, technically in degrees, this would be 180, and all the way at the bottom, this would be 270. So if you worked your way around, this is essentially where we'd be at. But with radians, we just measure it slightly differently. If I go all the way up, technically what we usually equate this with is 180 degrees is actually considered in radian world pi. So when we work with radians, every half turn around a circle is always pi radians around the unit circle. So instead of being 180 degrees, we would say that this would be called pi radians. Up above 90 degrees, because 90 degrees is halfway, half of the half, this is where this would be pi halves. It would be pi divided by 2. So 90 degrees is the same thing as pi halves. It's just that these are the radian measures of those. So all the way around, I always kind of think like all the way around, we would have one pi would be here, 2 pi would be here, and that's what 360 radians is. Or excuse me, degrees. 360 degrees is the same thing as 2 pi radians. 0 degrees is the same thing as 0 radians. And if you want to put the units with these, you totally can. But that just means halfway, like if I go 1 plus a half, that's going to put me at 3 pi halves radians, which is the equivalent of 270 degrees. So most of the time when we start working with radians, this is where it's actually more fraction work than anything else. Because if I have 2 pi thirds radians, I kind of like to think about where my main pieces are on this. So instead of in degrees, we're working in radians. This would be 0 radians. This would be pi halves radians. This would be pi radians. And this would be 3 pi halves. So if our job is to figure out where 2 pi thirds is, it really helps to kind of notice that when we work with our radians, it almost always is going to be, depending on where your quadrant is, it's more of a fraction problem than anything else. So obviously, if I'm working with pi halves is larger than pi thirds. So pi thirds would be in this quadrant, but we're working with 2 pi thirds. So how we usually go about finding where this angle would be is we are going to take the quadrant that it usually is going to end up being in. So if I'm looking at here, pi thirds would be in here, 2 pi thirds should potentially be in quadrant 2. But to figure that out, we just say, okay, well, pi would be halfway around. We're not quite halfway. 2 pi thirds, 3 pi thirds would be all the way around, or would be all the way to here. We're not quite 3 pi thirds. So I know I'm a little bit less than pi, or a little bit less than halfway. Now the question is how far you would be. So to do that, we would take essentially pi minus whatever angle is going to be. And really, as a fraction, remember, if you ignore the pi, 2 pi thirds to get common denominators, that would be 3 pi thirds. So 3 pi minus 2 pi is going to end up being 1 pi third. And that's the distance away from pi that you are. So I'm 1 pi third away, which is essentially just 2 pi thirds. And that's where my angle would end up being. If I look at 5 pi fourths, something that I notice is that 5 pi fourths is 1 more pi fourth away after pi. So if we look at our unit circle again here, 4 pi fourths, or pi, if you think about it, right? 4 pi fourths would be here. So 1 more pi fourth in that direction would put my angle here. So we would be a little bit more than 180 degrees. All right. So if we keep working, and we can keep doing this, we can go backwards too. 3 pi, this would be probably one of my favorite ones because pi, 2 pi, if I were to keep going, 3 pi, 4 pi. In radians, it's actually easier to count where you would end up being on the unit circle. So 3 pi would be 1, 2, 3 pi would fall on where 180 degrees would fall. It's coterminal with that. Now you can also go negative. If I'm looking at radians here, we're working in denominators of 5. So technically, if I was going to go pi, pi would be here, which in common denominators would be 5 pi fifths. But the one thing I'm noticing here is that it's negative. So negative just goes the opposite direction. So negative 5 pi fifths would be here. So if I'm negative 7 pi fifths, let's see, that would put me at my next one that I would go around would be 2 pi, which would be all the way around. That would be negative 10 pi fifths. And negative 7 pi fifths is a little bit less than that. So negative 7 pi fifths, we would check this out and we would say, well, that's 2 pi fifths away. So my angle is probably going to end up being somewhere kind of right in here. And that would be your negative 7 pi fifths. All right. So now we can also do the same thing here where we find one positive angle and one negative angle that are coterminal. The difference here, obviously, is when we worked with degrees, we would subtract 360 every time. So to find coterminal angles that are radians, we just use what the measurement would be for radians, which instead of 360 degrees, it's just going to be 2 pi. So to find my coterminal angles, both of these, we're going to add 2 pi and subtract 2 pi and kind of see where that gets us. So here, technically, this first calculation, I'm doing 3 pi fourths plus 2 pi, which if we get common denominators of pi fourths, I'm going to multiply this by 4 over 4, which is going to end up being 8 pi fourths. And now we can add 3 pi fourths plus 3 plus 8 technically is going to end up being 11 pi fourths. And that is what we would get. Subtracting 2 pi, we would do, well, 3 pi fourths minus 2 pi, which again, we would get the same common denominator. So it'd be 3 pi fourths minus 8 pi fourths. And I'm loving this because we're going to get our negative answer. 3 minus 8 is going to end up being negative 5 pi fourths. And there would be your negative coterminal angle. Now you're probably wondering, well, Ms. Hardy, there's 2 ways of measuring. Does it matter which way you use? Technically not. You do want to kind of keep in mind that I'm going to give you angles using both measurements. So it is helpful to know that there is a way to convert between the two. And the conversion is using the fact that pi is the equivalent of 180 degrees. So anytime you're converting between the two, this typically, either this or the reciprocal of this, is basically how we're going to convert. So to go from degrees and to say, well, how many radians is that going to be? We multiply by pi over 180 degrees. Now, multiplying fractions is a little bit different. Technically, you just have to take 300 times 1 over 180, and that's going to give you, we multiply the numerators together. So 300 times 1, which is 300. The pi is going to stay. And on the bottom, 1 times 180 is going to give us 180. So if we use our calculator and we reduce, if I do 300 divided by 180, that's going to reduce to 5 thirds. So 300 degrees is the same thing as 5 pi thirds. If you want to go the opposite direction, we just use the opposite conversion factor. To go from radians to degrees, which is usually the more common route to go, we're going to multiply by 180 over pi. And you're going to notice a couple of things happen. First of all, the pi's cancel. Pi divided by pi is just 1. Now multiplying, I'm going to multiply the numerators together. 3 times 180 is going to give me 540. On the bottom, 4 times 1 is really just going to end up being 4. And if we reduce, 540 divided by 4 is going to leave us with 135 degrees. So anytime you want to convert between the two, if you want to go from degrees to radians, we multiply by pi over 180. If we want to convert to radians to degrees, we multiply by 180 over pi. This is super helpful, especially if you are better working in degrees than radians. So that is something that you are going to want to know. Now, one concept that we like to bring back from geometry is arc length. And that's because the formula here to figure out what the measurement is going to be, we always plug in radians into this formula, actually. So here it says the softball field forms a sector with dimensions shown. Find the length of the outfield fence. Anytime you want to find the distance around the edge of the circle here, this is where we can use this formula. So to find the arc length, that is what S stands for. So if you want to find a specific sector, oh my gosh, that circle is so bad. Center of the circle there. If you draw a slice of pizza, if you want to find the arc length here, which we usually call S, it's always dependent on what the angle measurement would be. So kind of the nice part about this is that since this is in radians, we need to make sure it's in radians, but I already know the degree measure. It's technically 90 degrees, which is my angle on this one. So first thing we want to do is convert 90 degrees into radians. So that conversion factor, we're going to multiply by pi over 180. So 90 times pi is going to end up being 90 pi. 180 times 1 is 180. And if we divide those, 90 divided by 180 ends up being pi halves, which is our 90-degree measurement. So to plug this in, we take the radius, which is the distance from the center to the edge, which is 180. And we're going to multiply that by our angle, which is pi halves. And if you do so, you get an approximate answer of 282.74 feet. All right. So that's it for today, guys. You guys can now move on and you guys can start working on the homework for today.